After today's flip lesson, you should be able to identify and name simple ionic compounds. Previously, you've learned about the structure of an atom, the elements and atoms that make up the periodic table, and you've learned about what changes an atom makes to become an ion.
You might be thinking to yourselves, what is an ionic compound? Let us ease your pain and teach you. An ionic compound is a combination of a cation and an anion. To simplify, we will refer to this as a metal and a nonmetal. There are a few exceptions. In order to form an ionic compound, a metal has to transfer its electrons to a nonmetal. So here we see sodium is going to lose its electron, and chlorine is going to take its electron. So this is now going to become chloride because of the transfer of electrons. So here, once this transfer has happened, we now have an ionic compound of sodium chloride.
So how do you know what charge an ion will have? On your periodic table, do you remember where to find the charge of an ion? It's found on the lower half of the element box. Like a lot of atomic properties, the charges can follow a pattern on the periodic table. Where are the metals? What kind of charge do metals have? They are all positively charged. Where are the nonmetals? What charge do they have? They're all negatively charged. Look closer. What charge do all the metals in group 1 have? 1 positive. What charge do all the metals in group 2 have? They're all 2 positive. What charge do the elements in group 17 have? 1 negative.
Simple ionic compounds are made of only 2 different elements. Let's take a closer look. The first element must be a metal, and the second element must be a nonmetal. This is then going to form an ionic compound. Let's look at an example. Here we have sodium. Is sodium a metal or a nonmetal? Take a look at your periodic table. Sodium is a metal. Now let's look at chloride. Is chloride a metal or a nonmetal? Take a look at your periodic table. It's a nonmetal. When these two form and transfer their electrons to form a bond, this is now going to become an ionic compound called sodium chloride. I know, this is crazy stuff.
Now remember, to make an ionic compound which has a neutral charge, the number of positives have to equal the number of negatives. That's how we decide how many of each ion to put in a formula. Let's do an easy example to start with, sodium chloride. The sodium ion has a charge of 1 positive. The chloride ion has a charge of 1 negative. Since there are just as many positives as negatives, only one of each element is needed in the formula for sodium chloride. What about potassium oxide? Potassium has a charge of 1 positive. Oxide has a charge of 2 negative. Now the charges are unbalanced. There's one more negative than positive. How do we get more positive? We need more potassium. Now there are 2 positive charges and 2 negatives. When you write the formula for potassium oxide, you show that you use 2 potassium ions by using the subscript 2 after the potassium. Now a tough one, aluminum sulfide. The charge on aluminum is 3 positive. The charge on sulfide is 2 negative. The charges don't balance. We need more negative. How? More sulfide. Now there's 4 negatives, still unbalanced, and we need more positive. How? More aluminum. What the? Now there's 6 positives and 4 negatives. Keep going. We need another sulfide. One more gives us 6 negatives. and the charges balance. So what's the formula? It takes 2 aluminum ions to balance the 3 sulfide ions. So the formula is Al2S3. Nice! Okay, now it's time for you to try it. I'm going to give you a name and you have to get the formula. Be ready to pause the video on your computer, get a piece of paper, see if you can get the formula, and then when you think you've got it, play the video again and I'll give you the answer. Okay, just after I give you the question. Ready? All right, here we go. The first one, lithium bromide. Pause the video now. Okay, so you think you've got it, hey? Lithium has a charge of 1 plus. Bromide has a charge of 1 negative. The charges balance, so the formula is LiBr. Did you get it? Here's another one. Get ready to pause the video. Magnesium oxide. Pause the video and get the formula now. Okay, so you think you've got it? Magnesium has a Mg2 plus charge. Iodide only has a 1 negative, so there's more positives than negative. We need 1 more iodide to balance out the charges. That gives us 2 positives and 2 negatives, so the formula is Mgi2. How'd you do? Let's do a couple more. Get ready to pause the video. Give me the formula for calcium nitride. This is a tough one. Pause the video now. Okay, let's see if you've got it. Calcium is Ca2 plus, nitride is N3 negative. Charges don't balance. We need more positives. So if we put another calcium, we've got 4 positives and 3 negatives. They still don't balance, so we need more negatives. Here's another nitrogen. Nitrogen 3 negative gives us 6 negatives and only 4 positives. Well, how about another calcium? That gives us 6 positives and 6 negatives. Charges balance, so calcium nitride's formula is Ca3N2. How'd you do? If you got that one, you're doing a pretty good job. Let's do one more. This one's an easy one. Okay, get ready to pause the video. Can you get strontium oxide? Pause the video now and figure out the formula. Okay, let's see if you got it. Strontium has a 2 plus charge. Oxide has a 2 negative charge. Charges are already balanced, so there's only 1 of each. SRO is the formula for strontium oxide. Good job. Okay, now you're done the hard part. Just remember, when going from the name of ionic compounds to a formula, you have to balance the positive charges with the negative charges. Now we'll practice the easy part, going from the formulas to names. Before we start, remember that this is the rule for naming ionic compounds only. Since that's all we've done so far, it'll seem pretty easy, but there are different rules for compounds called molecular, and you'll get mixed up later if you don't know first how to know this is ionic. How do you know? For now, it's easy. If you see a metal with a nonmetal, it's always ionic. Ask yourself the question, is there a metal? If the answer is yes, then it is ionic, and you can name it with the following rule. When you have an ionic formula and you want the name, name what you see straight from the periodic table. You will name the metal ion first. It has the same name as the metal atom. You name the nonmetal next. Note that it is the ion you're naming, so it ends in IDE. So if I was given the formula MgO, I would first ask, is there a metal? Yes. Magnesium is a metal, so the compound's ionic, and I just name what I see. Magnesium oxide. The formula is Kf. I would first ask, is there a metal? Yes. Potassium is a metal, so the compound is ionic, and I just name what I see. Potassium fluoride. For the formula BaBr2, I would first ask, is there a metal? Yes. Barium's a metal, so the compound is ionic, and I just name what I see. Barium bromide. Make note, even though there are 2 bromide ions, I don't change the name. This is a different rule when we start naming molecular compounds. Just name the ions. This is barium bromide. Now we have Al2Cl3. I would first ask, is there a metal? Yes, aluminum's a metal, so the compound is ionic, and I just name what I see. Aluminum chloride. Just as a final note, remember that the names of chemicals are all lowercase. Okay, now it's your turn to start practicing. You're going to be going from the formulas to the names. Now, remember, you're going to pause the video. I'm going to give you a formula. You write down the name after you pause the video. Then you can play the video and I'll give you the answer. Remember that these are going to be pretty easy because we haven't done anything other than ionic, so these are all going to be ionic. They're all going to have a metal in them. Once you start mixing them together, you got to make sure that you ask yourself, is there a metal? Okay. So, try this one. CSF. Pause the video now and write down the name. All right, let's see if you got it right. Did you write cesium fluoride? Remember, just name what you see. Cesium's a metal, so it is ionic. Cesium fluoride is the name. All lowercase letters. Let's try another one. BES. Pause the video now and write down the name. All right, did you put beryllium sulfide? Great. Try Mg3P2. Pause the video and write down the name. Okay, did you get it? Magnesium phosphide. No, nothing to indicate the numbers, just name what you see. Magnesium is a metal, it's ionic, just name what you see, magnesium phosphide. Okay, let's try one more. Ag3N. Pause the video and write down the name. Did you get it? This one's silver nitride. If you need some more practice, you can always go to the textbook or online. There's tons of practice that you can do.